So we discussed angular displacement represented by letter theta. And what is angular displacement? It is the angle traced out by the radius vector in the given time while the object is rotating on a circular path. So this is angle theta. And theta we know, we have discussed, is equal to the arc PQ divided by the radius. It is measured in radian. Okay, and it is a what kind of quantity? It is a vector quantity. For small angles, for small theta. When theta is small, it is a vector quantity, but it ceases to become a vector quantity when theta is large. Now, angular velocity. Represented by letter omega. So it is the rate of time rate of change of angular displacement. Time rate of change of angular displacement when the particle or an object is moving in a circular motion. So once again we consider an object moving along a circular path. C is the center, it is at point P, it reaches a point Q while it is moving in the anti-clockwise direction, and this is the angular displacement, say delta theta, in time, small time interval dt. Then the angular velocity is given by omega is equal to angular displacement, that is delta theta, divided by the time interval in which the displacement has taken place. So this will be equal to limit so angular velocity omega is angular displacement divided by time interval or time taken, and this we write as the limit as delta t approaches 0, because this is the instantaneous value of delta theta by delta t. So omega at any instant of time is given by delta theta, the rate of limit of delta theta by delta t as delta t approaches 0, and this is equal to d theta by dt. So omega is equal to d theta by dt, and the direction of this omega, this angular velocity, and rule, like we had discussed right hand rule in case of angular displacement. So when we turn finger in the direction the object moving on a circular path, and the direction of thumb gives the direction of the angular displacement. Same way, the particle is rotating or moving on a circular path in the anti-clockwise direction. So stretch your right hand and curl your fingers in the direction of motion of the particle. Then the thumb will give you the direction of angular velocity. So in this case, the angular velocity is perpendicular to the plane in which the particle is moving on a circular path, and the direction of angular velocity is perpendicular to this. So we can show it like this. And when the particle is moving in the opposite direction, so initially the particle is at point P here and reaching the point Q here while it is moving on a in clockwise direction. So this is the angle delta theta. Now we have to stretch our hand in such a way that we curl the fingers in the direction of motion of the object. So we're curling it like this, and the direction of thumb gives the direction of angular velocity. So angular velocity now is perpendicular to the plane in which the circular motion is taking place and in the downward direction. And the units of angular velocity is radian per second. So it was radian in that case. Now unit in this case is radian per second, and the dimensions will be m0 l0 t minus 1. That is the dimensions of the angular velocity, and it is again a vector quantity because angular displacement is also a vector quantity. Okay, so anti-clockwise direction, the direction of angular velocity is upward direction, in the upward direction perpendicular to the plane, and in the clockwise motion the direction is downward perpendicular to the plane. Now we shall discuss the relation between linear velocity and angular velocity. That is between v and omega. So what is the relation between the two? Let us discuss now. Now let us say the object is moving with angular velocity on a circular path. O is the center. Let us say project at P at any time T, and R is the radius vector, and it reaches a point Q after small interval of time, say delta T, and the angle displacement is delta theta, and the radius vector now is R plus delta R. That is the position vector of the particle. So position of the particle when it is at P is R vector given by R vector. Position is given by R plus delta R vector when it is at Q. In time delta T, it has taken a angular displacement delta theta. And let us say its angular velocity is omega, and the particle is moving with linear speed v. So angular velocity is omega and linear speed of the particle is v. Okay. Now OP represents R, vector R, position of the particle. So OP vector represents the position of the particle at P, and OQ vector represents the position of the particle at Q, which is given by R vector plus delta R vector. Now V, the speed, is given by the distance traveled from P to Q, linear distance traveled from P to Q divided by delta T. Let us say the linear distance traveled, which is PQ, is equal to delta L. Okay, so it has traveled from P to Q like this. So let us say this PQ arc is equal to length delta L. So V will be equal to delta L divided by delta T, because delta T is the time taken, delta L is the length which has distance which is traveled by the object. And omega will be now, because omega is rate of change of angular displacement is delta theta, and time is delta T. So we get these two relations when the particle has moved from P to Q in small interval of time delta T. So this implies delta L, that is the linear distance traveled, is equal to V delta T and this implies delta theta is equal to omega delta t. Okay, now because angle is equal to arc divided by radius, this means this angle delta theta is equal to arc is delta L divided by radius is equal to r. So we have written delta theta in terms of the length of the arc divided by the radius. Okay, this is how we represent angle. So we can now put the values of delta theta and delta r in this. What we get is delta theta from here is, so yeah, this is delta theta and it is delta L. Put in this relation. So omega delta t is equal to delta L is V delta t divided by r. So we have simply written down delta theta is equal to delta L by radius, and delta theta is equal to omega delta t, and delta L is equal to V delta t. So we have just now, let us make some rearrangement, and what we get is, if this cancels with this, so omega is equal to V divided by r, or V is equal to r omega. So that is the relation between velocity and linear velocity and angular velocity. Okay, now the direction of V. Let us talk about the direction of velocity. So direction of V, now this as PQ, as delta t approaches 0, Q point will come close to P. When this approaches 0, the time interval approaches 0, because in this time interval the particle went from P to Q. Now when this time interval almost becomes 0, the Q particle will be very close to P. So if it comes close to P, you will see that this angle is increasing. So I'll draw it here once again. So bigger figure of this. So this is the center, this is the radius, the position vector P, and this is Q, and this is delta theta, and this is time in which it has gone from P to Q. So now look at this angle. So this angle, as the particle Q comes close to P when delta t approaches 0. So when it comes here, this angle increases. When it comes here, angle will further increase. When Q almost comes at P, the angle becomes 90 degree. So as particle Q approaches particle P, as delta t approaches 0, the PQ vector becomes tangent to the circle at point P, because PQ vector now becomes perpendicular to the radius vector OP. So PQ becomes perpendicular to vector OP. So that means PQ becomes tangent to the circle at point P. So that is the direction of linear velocity. So linear velocity is always along the tangent to the circle or the circular path at given point. तो जिस पॉइंट पे हमें वेलोसिटी निकालना हो, लीनियर वेलोसिटी हमेशा उस पॉइंट पे सर्कुलर पाथ के टेंजेंट होती है. तो P पॉइंट पे देखेंगे तो ये डायरेक्शन है वेलोसिटी की, Q पॉइंट पे ये डायरेक्शन होगी, और यहाँ पे कोई S पॉइंट है तो ये डायरेक्शन होगी, और यहाँ कोई और पॉइंट है तो ये डायरेक्शन होगी. तो दिस इज हाउ द डायरेक्शन ऑफ linear velocity keeps on changing depending on the position of the point on the circular path. So this is about relation between linear velocity and angular velocity. Acceleration. Angular acceleration is defined as the time rate of change of angular velocity of an object in circular motion. So it is the time rate of change of angular velocity while the particle is rotating or moving on a circular path. It is represented by letter alpha. So if there is a change in velocity in small time interval, suppose delta omega is the change in velocity, your angular velocity in time delta t. Then alpha is given by limit as delta t approaches 0, delta omega upon delta t. And this we can write down as d omega by dt. So alpha is equal to d omega by dt. The first derivative of angular velocity with respect to time. Okay, and the unit radian per second square, and the unit is radian per second square, and the dimensional formula is m0 L0 t minus 2. Okay. Now relation between linear acceleration and angular acceleration. So linear acceleration and angular acceleration, that is A and alpha. So A is linear acceleration, alpha is angular acceleration. We know the relation between V, linear velocity, and angular velocity, that is V is equal to omega r. Differentiate both sides with respect to time. dV by dt will become ddt of omega r. Now r is a constant quantity, so will be equal to dvt d omega, and this is r. Okay, and what is dv by dt is A, that is linear acceleration, d omega by dt is r as it is, and d omega by dt is the angular acceleration, that is alpha. So A is equal to r alpha. That is the relation between linear acceleration and angular acceleration. So you have studied this in class 9 also. When a point object is moving on a circular path with a constant speed, then the motion of the object is called uniform circular motion. So if there's a circular path and object is moving on the circular path with constant speed, that means it travels equal distances in equal intervals of time. Then we call this uniform circular motion. And what is the time period of uniform circular motion? So T, it is represented by capital T. So capital T represents the time period of uniform circular motion. So it is a time taken by the object to complete one revolution on its circular path. तो जितने टाइम में अगर यहाँ से जाने में पार्टिकल को P से जाके वापस P पे आ जाता है, तो जितना टाइम लगता है उसको हम उसका टाइम पीरियड बोलते हैं. So time taken by the particle to complete one revolution is called the time period of uniform circular motion, and it is represented by T and its unit is second. Okay. Now frequency of uniform circular motion. It is represented by letter nu. So what is the frequency? It is the number of revolutions completed by the object in unit time. So number of revolutions per unit time is called the frequency. So जितने मान लीजिए 1 सेकंड में इसने 10 रोटेशन कंप्लीट किए तो उसका फ्रीक्वेंसी कितना होगा 10 आरपीएस रेवोल्यूशंस पर सेकंड. उसको बोलेंगे 10 revolutions per second. It is uniform. It is called the frequency represented by nu, and its unit is either per second or hertz, or we also call it rps. Rather, these are the units: hertz and per second, represented by letter nu. So nu, this is called nu and slightly similar to V. Okay, now relation between time period and frequency. Relation between time period and frequency. That is between T and nu. Suppose nu is the frequency of revolution of the object. That means nu number of revolutions are completed in take 1 second. Frequency is equal to nu, and suppose the angle that is traced by the object at its axis while it is moving on a circular motion is 2 pi, and suppose T is the time period, and the angle traced by the object is 2 pi. तो ये जो है ये सर्कल है, सेंटर है, तो एक्सिस इसमें जा रही है, इस तरह से पार्टिकल मूव कर रहा है, और इस पे जो है ये 2 पाई एंगल कंप्लीट कर रहा है. 2 पाई मतलब एक चक्कर इसने पूरा कर लिया. तो एक चक्कर पूरा कर रहा है, 2 पाई एंगल कंप्लीट कर रहा है, तो टाइम कितना लगेगा? सो टाइम टेकन इज इक्वल टू टी, दैट इज द टाइम पीरियड. Time period is what? Is the time taken by the particle to complete one revolution. So time period, time taken will be equal to T, and the angular displacement will be equal to 2 pi. So we'll write down theta is equal to 2 pi while the time taken is T. Now from the definition, the velocity, angular velocity omega is equal to theta divided by T. Now if theta is 2 pi, time is capital T here, which is equal to the time period. So therefore relation between these two will be equal to, so this will omega, this implies omega is equal to 2 pi divided by T. Now 1 by T is also equal to nu. So omega is equal to 2 pi nu. So this is the relation between the angular frequency and the velocity, frequency, normal frequency, and this is a relation between angular frequency and time period. So this is a relation between time period, frequency as well as angular frequency. तो सभी का रिलेशन आ गया इसमें, टाइम पीरियड और एंगुलर वेलोसिटी का रिलेशन भी आ गया और फ्रीक्वेंसी और एंगुलर वेलोसिटी का भी रिलेशन इसमें आ गया. Centripetal acceleration. Suppose a particle is moving on a circular path with uniform velocity. Then you will see that the velocity vector at any instant, suppose at t, is along the tangent. So it will be in this direction. And when the position of the object changes, the direction of the velocity vector also changes. So at different positions, the direction of velocity vector is different, though the particle is moving with uniform speed. So whenever there is a change in velocity, so change in velocity means either change in the magnitude of velocity or direction of velocity or both. So in this case, the velocity vector direction is changing. So that means velocity is changing. So whenever there is a velocity, changing velocity, we call it accelerated motion. And therefore, we say that in this case, uniform circular motion is an accelerated motion. So it is an accelerated motion because the direction of velocity is changing while the particle is moving uniformly on a circular path. So what is centripetal acceleration? It is the acceleration of an object undergoing uniform circular motion. Is called the centripetal acceleration. So that is the definition of centripetal acceleration. And we must remember the direction of centripetal acceleration is always towards along the radius towards the center. So acceleration direction is along the radius towards the center. You will find out better when we proceed further. Now let us get the expression for this uniform circular motion. Once again, consider a particle so I'll draw it here only once again. Let us consider a particle of mass m moving with uniform speed on a circular motion, on a circular path. So uniform speed is v. The mass of the particle is, say, m. So uniform speed is v and angular velocity is omega. Okay, and the radius is r. Okay, so I'll write down here uniform speed is v. So these are some of the quantities, and center is O. O at the center. Let us say the particle at any time t is at point P. Particle is at point P at any time t. So this is the position vector, also the we'll call it, it is also equal to the magnitude is equal to radius. So OP vector is the position vector of the particle at point P at any time t. Let us say after a small time interval dt, or at time t plus delta t, that is after time interval delta t, the position of the particle is at q. Okay, so OQ vector, let us call this OQ vector as vector R2. So this is R1 and this is R2. So this is R1 and this is R2. So this is at time t plus delta t. Now from this, because it is a circular path, and this R1, the magnitude of R1 vector plus and is equal to magnitude of R2 vector, it is equal to the radius R. Okay, and what is the angular speed? Angular speed of this angle is delta theta, that is the angular displacement in time delta t. So delta t is the time in which this particle has gone from P to Q through angular displacement delta theta. Then omega, the angular velocity, is equal to delta theta divided by delta t. Okay, now draw the velocity vector at P and Q. Because the particle is moving in this direction, the velocity vector is given by the tangent at this point to the circular path. So these are the velocity vectors. Let us call this velocity vector v1 and this is v2. So v1 and v2 are the velocity vectors at point P and Q. And because the speed is uniform, so we'll write down that v1, its magnitude, is equal to v2 is equal to, say, v, because the motion is uniform circular motion, and these are represented by vectors PA and PB. So I'll write down here PA vector is equal to v1 vector, PB vector is equal to v2 vector. Now, because we want to find out the acceleration, we must find out the change in velocity, because acceleration is what? It is a rate of change of velocity. So time is given, that is delta t, but we have to find out the change in velocity. How the velocity has changed from v1 to v2. To find out that change, let us draw a vector p dash a dash equal to vector v1. Take a point O. P dash and draw a vector equal to